space friend, you know what can detect a magnetic field? A Hall effect sensor. And you know what tends to have a magnetic field? Habitable planets. And you know what could potentially be on a habitable planet? Aliens who will judge us. So I'm going to hook this Hall effect sensor up to a buzzer so that we'll get an alert if we come across one of these potentially habitable planets. There's no flaw in this premise, and I will be taking no questions. The Hall effect can be used to determine if a substance is an insulator or a semiconductor. The Hall effect's principle is that when a current-carrying conductor or semiconductor gets introduced to a perpendicular magnetic field, a voltage can be measured at the right angle to the current path. Being able to get a measurable voltage this way is called the Hall effect. A Hall effect sensor's output varies based on the presence of a magnetic field. The measured voltage provided by this effect can be used to determine if the sensor is in proximity to a magnet. The Arduino then detects the voltage change through its interrupt pin. These sensors are used for a variety of things, most of them less stupid than what we're using it for today. They can do practical things like count rotations by applying a magnet to anything that rotates, or detect fuel levels by sensing the position of a floating element in a fuel tank. For this project, we need the Hall effect sensor, a buzzer, a breadboard, and 8 jumper wires. Connect the VCC pins to the positive sign on the power rail, the ground pins to the negative sign on the power rail. The Hall sensor's pin goes to 2 and the buzzer sensor pin goes to 7. Then connect a jumper wire from the positive sign on the power rail to 5V and one from the negative sign to ground. Pin 2 on the Arduino is one of its interrupt pins, so that's what we're connecting the Hall effect sensor to. In void setup, we need to set the sensor as an input and the buzzer as an output. In the loop, we're reading in the state of the Hall sensor and setting that to a variable called state. If the state is low, which in the case of this sensor means that it is detecting a magnetic field, then we're going to have the buzzer go off. The tone function takes 2 arguments, the pin and the frequency. You can change the frequency in that second parameter to make the sound higher or lower. Next, in the if statement, if the sensor is not detecting a magnetic field, we're going to use no tone to tell the buzzer to just not make any noise. So one heads up, just a thing about how sensors work. Usually the modules that come in sensor kits have got VCC, ground, and an S for the sensor very clearly labeled out. The Hall effect that I'm using here, I'd purchased individually because I fried my other one. So this is a good example of a sensor that doesn't have the pins very clearly labeled. They do still have an S though, so the S is the sensor pin, the minus sign is the ground pin, and the VCC pin is in the middle. That one isn't labeled, but it's almost always going to be in the middle. And now to the fun part, because I am unreasonably excited to use a buzzer again. So right now the no tone function in the loop is executing because we are not near a magnet. Place a magnet near the sensor. Habitable planet alert! Well, I'm going to keep our matrix display that declared our ship as legitimate salvage handy just in case this Hall effect alarm ever goes off, because no project is as comforting to me as the ones that protect us from alien judgment.